everyone. Today we're going to be looking at bisectors of triangles. This is a section or a topic that has a lot of information, so I'm going to break it up into two videos. So look for the second video for sure. Alright, so the first bisector we're looking at is what's called a segment bisector. And a segment bisector is a segment line or plane that intersects another segment at its midpoint. Okay, so basically when we say it bisects, it cuts it in half, and you can see that from this first drawing here. Okay, this and this are congruent, so it cut it directly in half. The second one is what's called a perpendicular bisector, and perpendicular means it meets at a right angle. Okay, it still cuts it directly in half, but it creates then a right angle. So we've got those three parts. Okay? Alright, so what this leads to is a couple different theorems. First theorem is called the perpendicular bisector theorem. And the perpendicular bisector theorem says if a point on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. And now it has a converse, which basically just means it flips around. If the point is equidistant from the endpoints of the segment, then it's on the perpendicular bisector. So here's what that means. Let's say this CD is a perpendicular bisector. So this line right here cut this AB directly in half. Okay, so this side is congruent to this side. Notice we're also at a right angle. Okay? Any point along CD, okay, so in this case we've got C, will create congruent segments on those legs. Okay, so each of those lines will be congruent. And that will always be true as long as it is a perpendicular bisector. Okay? So if I drew this line down here and I created those, that would mean that these would also be congruent. Okay? So those segments would be congruent from those vertices. Alright, so here is this. How does that help us? Alright, so WX is 25.3. So this right here is 25.3. YZ is 22.4. Well, we know that this is 25.3. They've given that to us as well. Okay, find X, Y. Pretty simple, straightforward problem. This is what's given to us. Well, because of these, we know for a fact that's going to be 22.4, and there's your answer. Now, another way of looking at this is because these two are the same, that means that these two have to be congruent, and that would be 22.4, and there's your answer. Okay, so that's kind of what they're telling you and expecting you to get out of this. Now, the second one here says M is a perpendicular bisector, WZ is 14.9. What's WX? Well, same thing. Since it's a perpendicular bisector, these two are congruent, so this is 14.9, and there you go. Alright, so that's the whole idea behind perpendicular bisectors. They cut them in half. Alright, now the last one here. M is a perpendicular bisector. We know. WX is 4A minus 15. WZ is A plus 12. We want to find WX. Well, think about it. What do you know about these two things? They're congruent. So if they're congruent, I can set them equal. And that's one thing you guys should start and hopefully see by now is congruent things, you set them equal. So we've got our equation now, we solve. So subtract A, add 15. So those cancel. You've got 3A equals 27. Divide by 3. And that gives you the A equals 9. Okay, well, it's not asking for A, it's asking for WX. So I can substitute this right here and get 9 plus 12 equals 21. Well, what I found is actually WZ. But what do you know about WX and WZ? They're congruent, so that means that WX is also 21, and so there's your answer. Alright, so that's kind of how you're going to use this property. Just understanding that the sides from those perpendicular bisectors are going to be congruent. Now what this leads to is a couple different points, and we're going to talk about these points. Like I said, there's two videos. The second video is going to cover a few more. Okay, if you have three lines that intersect at a common point, that point, or those lines are called concurrent lines. The point is called the point of concurrency. So if you have three or more points that intersect, or three or more lines that intersect at that point, the point is called the point of concurrency. And we're going to see a few of these points of concurrency here in the next few minutes. Now, for any perpendicular bisectors, we're going to have three for any triangle, okay? Because they come off of those sides, one per side. The place where the three of those meet is called the circumcenter, and it happens every single time. Every perpendicular bisector will always intersect at the same spot. Okay, and it is called the circumcenter. Now, that leads us to a circumcenter theorem. The circumcenter theorem says the perpendiculars of triangle bisector, or of a triangle, intersect at a point called the circumcenter, which we already talked about, and they are equidistant from the vertices. Okay, so look at my picture here. Right here is my circumcenter. That's the place where those perpendicular bisectors intersect. Well, what that leads to are these lines. Okay, I'm going to give them 4 lines here. Those 4 lines that go from your circumcenter back to the vertices are all equal distance. So PA is equal to PB is equal to PC. And this is a theorem, so it's been proven. Okay, so from now on, if they give you something like this, they tell you you have a circumcenter, they're telling you that the distance from that circumcenter back to the vertexes, or the vertices, is congruent. Alright, now what happens is we got 3 different possibilities. Okay, and you'll see this coming up soon. 3 possibilities. We've got an acute angle, obtuse angle, and a right angle. Okay, the acute angle, which you see the picture here, the circumcenter happens inside that triangle. On a obtuse triangle, that circumcenter actually happens, intersects on the outside of the triangle. And for a right angle, they intersect on the sides, so on one of the legs or the sides of that triangle. Now, this is something that you guys will see in the discussion online, so definitely go there. Okay, check that out, and I'm asking you to just create some of these on your own and see if this holds true. Alright, so that's the end of the first video. Okay, we got the circumcenter, perpendicular bisectors. Watch for those. Okay, tune into the second video and see the rest of this section.